Today, we're going to show you how to assemble the Solar Tracker version 3 from Brown Dog Gadgets. You'll find all these parts included in your kit. Before you begin, zero your servos. Find the two servos and remove them from their bags. Take any of the plastic servo horns also included in the bags and push onto the servo axle of one of your servos. Using the servo horn, hand turn the servo axle clockwise until you cannot turn it any further. This is the zero position of that servo. Remove the servo horn and use the same process to turn the second servo axle to its zero position. Using two of the matching screws found in each servo bag and a small Phillips head screwdriver, mount one of the servos as shown onto the circular Solar Tracker platform. The hole is rectangular, so make sure you put the servo into the hole so that the rotor of the servo is centered in the circular disc. Use the wood screws to hold the servo in place. The servo will look like this when it's fully mounted. Take the circular platform, find the 4 platform legs and 4 screws and nuts. Bracing it from behind with a finger from one hand, seat a single nut in the slot of one leg position. Next, seat a single wooden leg as shown. Thread a single screw through the hole in the wooden leg and hand tighten to the nut behind it. Use your screwdriver to fully tighten, cinching the leg in place. Repeat the process for the other 3 legs. It should look like this when you're all done. Using the wooden servo plate shown and the 2 matching small screws found in the last servo bag, mount the remaining servo using your Phillips head screwdriver. Make sure that the wires and the servo axle are towards the rounded end of the wood piece. Tighten down the wood screws. Gather the wooden parts shown and 4 screws and nuts. Seat the tabs of the servo mount in the single slots of the 2 long wooden pieces. Pinch and hold them in place, making sure the servo axle is facing outward. Insert the remaining 2 matched wooden pieces into the slots at the opposite end of the longer pieces. Make sure their curved ends match the orientation of the curved end of the servo plate. Pinch and hold together. Fit the assembly onto the base. Seat a single 832 nut into one of the slots, bracing it from behind with a finger from one hand. Thread a single screw through the corresponding hole on the other side of the circular piece and tighten it to the nut with a small Phillips head screwdriver. Repeat these steps for the other 3 nuts and bolts. If you find it difficult to hold the entire assembly while trying to insert the screws and nuts, you could do something like make use of rubber bands to act as temporary clamps for the assembly. Or have a partner give you a hand while working on any part of this project. Select the black plastic servo horn from the servo bag. Find 2 of the 4 gold screws included in your kit. On a flat surface away from the wooden assembly, screw one into the hole second from the center of the servo horn and the other into the 3rd hole from center on the opposite side. Turn each of these 2 screws so that their tips just barely poke out the back of the servo horn. This will help you keep this part aligned while screwing it into the wooden assembly. Place the servo horn in the center of the non-etched side of the circular piece so that the screw tips are aligned with the pre-made holes. Use the screwdriver to tighten the servo horn in place against the wood plate. Gather the solar panel mounting plate, the single 1/2 inch long screw, a nut, and the small circuit board with 4 photoresistors on it. Position the circuit board as you see here so that the metal pins on the back drop through the rectangular hole on the wooden piece. This should allow the circuit board to lay flush against the wooden plate. Thread the 1/2 inch screw through the hole between the 4 photoresistors and use a nut and screwdriver to tighten it down to secure to the wooden plate. Gather the assembly from the previous step, 2 3/4 inch long screws, 2 nuts, and the 2 slotted wooden pieces shown. Fit the 2 small wooden pieces together as shown by sliding the larger of the 2 pieces atop the smaller by the slots. Press the cross divider assembly in place atop the circuit board so that the pegs fit into the holes on the larger plate. Use the 2 screws and nuts as you have in previous steps to join the cross divider assembly to the larger plate. For our next step, we'll need a wooden side brace, a servo horn from the servo bag, and the remaining 2 gold screws. We'll get those gold screws started into the servo horn off to the side, and we'll do this over a mat so we don't accidentally scratch our table. Make sure this round part of the servo horn is up, and then insert one of the gold screws into the servo horn, 1 hole in from the end. Screw it in far enough so that just the tip pokes through. Then repeat this with the other screw. Use the barely showing screw tips to guide placement of the servo horn where shown in the video. Tighten the screws in place to secure the horn to the wood. Gather the 2 side braces, one has a servo horn attached now, the etched solar panel plate with divided photoresistors, 4 screws, and 4 nuts. Fit the servo horn side brace to the back of the solar panel plate on the left-hand side. The servo horn should face inward. Secure in place with 2 screws and 2 nuts. Fit the remaining side brace into the slots on the right-hand side of the panel plate with the same orientation as the other. Use the remaining 2 screws and nuts to cinch the brace to the underside of the plate. Here's what it looks like when the sub-assembly is complete. Now we're going to put together the 2 sub-assemblies. Looking on the back, here we have the servo horn on the right-hand side. And then over on the other component, we have the servo with the servo axle sticking out to the right. Set the bottom of the solar panel plate right down onto the circular part here, and then rotate the 2 sub-assemblies together and slide the servo axle into the horn. Now keep in mind that earlier we zeroed the servo, so whatever angle you assemble this at is going to be as far vertical as the servo can go. You'll notice there's a hole in the wood here. We'll take a screw that came with the servo, put it through the wood, through the servo horn, and into the servo axle. Turn it clockwise until it's snug. The servo and the solar panel tilt plate are now solidly connected together. Locate the longest screw in your kit and thread it through all 3 holes in the wooden pieces on the opposite side of the servo connection you just made. Place a nut on the long screw and snug it down, but do not over tighten. This screw functions mostly as an axle that allows the plate above to swivel, so it needs to have some working space. Once that screw is installed, you'll be able to see how the solar panel can tilt, powered by the servo. Now to work on the base. Gather the large engraved base plate and the circular assembly from earlier, as well as 4 screws and 4 nuts. Fit the legs of the circular assembly into the slots of the engraved side of the base plate as shown. Use the 4 screws, nuts, and screwdriver to join the circular assembly to the plate. Do keep in mind that we now have some screw heads on the bottom of our assembly, so if you don't want to scratch up your table, you might want to use a piece of scrap cardboard or some sort of a mat to protect the table. Now we're going to connect our base to the upper half of our project. Remember, here's the servo axle, and underneath here is the servo horn. We're going to put the 2 of those together. And if we look from the top, we can see right through the servo horn. That's where we'll put a screw in just a moment. So we need to align both parts and then press straight down to connect them. Now keep in mind that if you zeroed out your servo earlier, this is going to be as far clockwise as the tracker can turn. And here we can see, if we just gently turn it back and forth, the range that we have with the servo. Now we need to insert the servo screw. To do that, you'll want to tilt the solar panel plate so that we can get a screwdriver down in here. You might find it easiest to tilt that almost vertical. You may also find it handy to use a magnetic screwdriver to hold the screw on the tip of the driver as you get it down to the servo horn. Then just tighten that screw all the way to connect the base to the upper part of the solar tracker. You can now gently rotate the tracker to see its range of motion and how it will pan and tilt. Next, we'll attach our battery pack. This is a 3 AAA battery holder, and it's going to go on the plate right here over these 2 screw holes. We'll use 2 M3 flathead machine screws. Those will go through the plastic battery holder, through the wood plate, and then we'll use the nuts on the other side to connect this all together. Tighten down the nuts and screws with your screwdriver. A note about the battery pack. Your Arduino is powered by USB and must be plugged in to work, but the battery pack is a separate power supply giving reliable power to the servos and must have batteries installed. Next, we'll need 4 screws and nuts and our Arduino board. We'll want to make sure that the USB connection faces this direction, and we're going to put it right over these 4 screw holes in the board. Secure the Arduino to the solar tracker assembly by tightening the 4 screws to the 4 nuts with your screwdriver. Sometimes it's really tight to fit this 4th screw in. If you can't, that's fine. Leave it out. 3 screws will hold the board on just fine. Next, we'll install the voltmeter. We'll need 2 wooden side brackets along with the voltmeter itself and a pair of screws and nuts. Fit the tabs on the side of the voltmeter into the wooden supports. Then pinch the whole thing together and insert into the remaining holes of the base plate. Secure these in place with screws and nuts. Find the Arduino shield and orient it to match the Arduino board. Take care to line up all the pins from the underside of the Arduino shield with the holes on the Arduino. Firmly press the shield straight down to seat the pins in their respective holes and connect the 2 boards. Now let's add some feet to the tracker. Flip up the solar tracker and find the 4 self-adhesive feet that come in the kit. Peel them off and stick one each in the 4 corners of the solar tracker. This gives a non-marring, non-slip, stable base to the solar tracker. Find the solar panel and Velcro strip in your kit and peel one side of the Velcro backing off to reveal its sticky side. Leave the opposite side backing intact. Press the Velcro in place as shown on the back side of the solar panel. Thread the long wires through the hole in the wood mounting plate. Peel the remaining backing from the Velcro, which is now attached to the solar panel. Pull the wires the rest of the way through and press the solar panel in place atop the mounting plate as shown. Using a wire stripper, remove about 1/4 inch of insulation from each of the 3 wires that are connected to the voltmeter. Twist together the red and white wires from the voltmeter to the red wire from the solar panel. Twist together the black wire from the voltmeter to the black wire from the solar panel. Find the 2 wire nuts included with your kit. Use one of them to tighten down onto the bundle of black wires. Turn it clockwise and tighten it until it's snug. Take the other wire nut and connect it to the bundle of 2 red and 1 white wires. Turn clockwise until it's snugly tightened down. Now let's connect the servos. At the upper servo, grab the connector at the end of the wires and plug it into row D6 on the Arduino shield. D6 is all the way at the left-hand side of the digital outputs. Make sure that the brown wire is connected to the ground side of the connections. Take the wires from the lower servo and plug them into the row of pins labeled D5 as shown. Again, orient them so that the brown wire connects to the column of pins labeled ground. Now we'll connect our wiring to the photoresistor circuit board. We'll do this with a ribbon cable. Your cable might be different colors than what's shown here. That's okay. What's important is the order and orientation of the wires. Plug the cable in to the photoresistor board. Note the color of the topmost wire you plugged in. Find the other end of that wire and plug it into the analog pin labeled A0 on the Arduino shield. Note the second wire from the top. Go to the other end of that wire and plug it into the analog pin labeled A1 on the Arduino shield. Continue this for the rest of the wires except for the very last one. For the very bottommost wire plugged into the photoresistor, take the other end of the wire and plug it into the pin marked 5V in the A0 column, right below your very first wire and next to the white dot screen printed on the board. Now let's connect the battery pack power. At the Arduino shield, loosen the screw-down terminals at the input power connection. Insert the red positive wire to the connection marked with a plus and tighten down the terminal. Insert the black negative wire to the terminal marked with a minus and tighten down the screw. To upload the code that controls the solar tracker, you first need to download the Arduino programming software to your computer and connect the Arduino on your solar tracker to your computer by USB. From the Tools drop-down menu, make sure you select Arduino Uno and that you have the correct port. Open up a new project window by selecting New from the Files drop-down menu. Copy and paste the version 3 code into the project window you just opened within the Arduino software. The code can be found at the link in the video description and at browndoggadgets.com. Click the check mark at the top left of the project window to verify, then click the arrow to upload. The code will run as long as the solar tracker is powered up. Remember, you need 3 AAA batteries to power the servos and the USB connection to power the Arduino. A great way to test the solar tracker is by using a flashlight. Move the light around and see how the solar tracker follows it. Have fun with your solar tracker, and come visit us at browndoggadgets.com for more projects and resources.